Hi, Luke again, here for the fourth session on Introduction to Programming for Teachers using the Python programming language. Today we're going to be focusing on decisions. So the content of today's session is going to be implementing decisions using an if statement. It's going to be the main focus of today's session. How we compare integers and strings, how can we use pen and paper to follow what a program does, and then right at the end, we're going to have a slightly more complicated section on comparing floating point numbers. So the main focus, or the main starting focus for today, is going to be the if statement. So a computer program often needs to make a decision based on input or circumstances. For example, buildings often skip the 13th floor when they're building them, right? And elevators, therefore, should do the same. The 14th floor is actually the 13th floor, but it's not called the 13th floor, it's called the 14th floor. So every floor above 12 is really the floor number minus 1. The 14th floor is actually the 13th floor, the 15th floor is actually the 14th floor, and so on. So if your floor number is greater than 12, then the actual floor you're on is the floor number minus 1. Okay, and the two keywords of the if statement that we're going to be using are if and else. So in this nice little yellow box here, we have the if statement that allows a program to carry out different actions depending on the nature of the data that's being processed. And then up here, we've got a photo of a lift, and you can see that it goes 10, 11, 12, 14. There's no 13th floor. One of the ways we can visualize an if statement is using a flowchart. So we have our flowchart coming in. It asks us a question. Is the floor number greater than 13? And this can only ever be evaluated to true or false. Either it is greater than 13 or it's less than 13, or less than or equal to 13. One of the two is either true or false. So if the floor number is greater than 13, this is true, then our actual floor is the floor number minus 1. If we're on the 15th floor, we're actually on the 14th floor. 15 minus 1 is 14. If we're on, let's say, the 9th floor, so 9 is greater than 13, well, that's false. So we run this set of code, which says the actual floor is the number of the floor we've got. So we are actually on the 9th floor when we say we're on the 9th floor. Okay, so we have a true if branch and a false else branch. How this flowchart would look in something like Python is we'd have if floor is greater than 13, and then a colon, actual floor equals floor minus 1, so the condition, the code to be run if the condition is true, else actual floor equals floor. Okay, and this is the code to be run if the condition is false. You can create if statements without this else branch. So if something is true, do this code. The else or the false just doesn't do anything extra. There is nothing specified to run on the else condition. So in our example here, we've got actual floor equals floor, and then if floor is greater than 13, run this set of code here, which is the information to be run if the condition is true. So let's look at the syntax of the if statement and how we actually write them in Python. So we start off with our if, and then we have a condition. And that condition is either going to be true or false. Often it uses relational operators like comparison, checking if things are not equal to each other, less than or equal to, greater than or equal to. Following our condition, we have a colon. The colon indicates a compound statement. And then the next line, which is indented, one tab, is the code that's going to be run if the statement is true. So if the condition is true, the statements in this branch here are executed in sequence. If the condition is false, this line of code is going to be skipped. Okay, then we have our else statement. So this is if it's true, do this. If it's false or else, do this code. So if the condition is false, the statement in this branch here will be executed in sequence. If the condition is true, this line of code is going to be skipped. Okay, Couple of things about alignment. The if and the else are aligned at the same level, whereas the branches and the code to be running those branches is aligned one step in. That's one tab of space. We can omit the else branch if there's nothing to do. As we saw in the previous example here, there is no else branch. Okay, so here is a quite a simple program which demonstrates using ifs and elses, as well as some of the things we looked at in previous sections about taking input and providing output. So we're going to ask the user to input the floor number they're on. We're going to convert that string into an integer and store it in the variable floor. And then we're going to adjust the floor if necessary. So if our floor is greater than 13, then actual floor is floor minus 1, else actual floor equals floor. And then finally, we're going to print the result by saying print, the elevator will travel to the actual floor, actual floor. Okay. Have a go, pause the video, copy that down. Have a little go at writing the if statement and making sure you remember the colons and the indentation of actual floor of these branches that are going to be run. If and else should be on the same alignment. Have a little play around with it, see if you can get it working. Okay, and then if you, for example, enter that you're going to the 20th floor, you should get the printed out statement, the elevator will travel to the actual floor 19. Okay. Some quick tips on indentation. Some people use spaces instead of tabs. I use tabs. The suggestion here is to use spaces, so kind of choose whichever one you prefer, but be consistent. Don't mix tabs and spaces. Don't use spaces sometimes to do your indentation and tabs to do the other side. Other times, always stick to one, either spaces or tabs. So we've got our if total sales is greater than 100, 0, colon, and then this is indented one level, a certain number of spaces or one tab, discount equals total sales times 0.5. All of this is going to run, all of these 3 lines of code from discount to the print are going to run in sequence if the if condition is true. Then we go back to an else statement, which is in the same alignment as our if, alignment level 0, or indentation level 0. And then this is the code that's going to run if it's false. So if total sales is less than or equal to 100. We've got a diff equals 100.0 minus total sales, fine. And then we've got another if statement, which is running inside this else statement. And then all of the information in there is going to be indented, again, one more level. Okay, so this print line is only going to run if the total sales is less than or equal to 100, so the else statement runs, and then if the difference is less than 10.0. We've got an else. This else is aligned with this if at indentation level 1, not indentation level 0 because it's being contained inside this else statement from the original comparison or the original decision. And then this final print you need to spend blah, 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 blah is contained within this else's condition. This is the code that we're going to run if the else condition is true. So that's indented another level. So this indentation level stuff is referred to as block structured code. Indenting consistently is not only syntactically required in Python, but it also makes the code much easier for humans to follow. Okay. So maybe this is something, again, that you might want to stop and kind of have a go at typing out just to see how it feels and kind of get the idea of doing different indentation levels, if statements within if statements, and how the indentation levels work there. Okay, we'll highlight some common errors that occur. So we typically want to avoid duplication in branches. So if the same code is being duplicated in each branch, then it doesn't actually need to be inside the if statement. We can just run that duplicated code outside the if statement. Okay, so in the example here, we have a print statement, print actual floor is, and then the value stored in the variable actual floor, and we've got that both inside the if statement and inside the else statement. So to save ourselves doing that, we can actually just put it outside the if-else statement. So the if statement now calculates if floor is greater than 13, calculates the actual floor is floor minus 1, else actual floor equals floor, and then when that's finished, it does the print statement, rather than having to write the print statement out twice. Again, take a second, copy this down, run it, and just check to see that these two things do the same. They produce the same result, and they work as you expect them to. Okay, so currently we've kind of looked at this symbol, this greater than symbol, and earlier on I said that there were a couple of other comparisons we could do, and these are called relational operators. So every if statement needs to have a condition, and usually that condition is comparing two different things with some sort of operator. So we could have greater than or equal to, less than or equal to. Double equals is just checking that the two things are equal, because remember, a single equals is for assignment, a double equals is for comparison, and then exclamation mark equals is checking that they are not equal. Okay, if we look at our table here, we've got greater than, which is the same as it would be in maths, greater than or equal to, which looks like this in maths and this in Python, less than or equal to. This is the one we need to be aware of. Double equals is for comparison, because single equals is for assignment. And then right at the bottom, we have exclamation mark equals, which is the symbol for not equal. Okay, so we've looked at comparing the integer value stored inside a variable with another integer. Well, we can also compare strings. So we can check if two strings are the same. So if name1 is the same as, or equals, is equivalent to name2, print, the strings are identical. Okay, we could also use a if name1 is, and then this is the symbol for not equal to, name2, print, the strings are not identical. For two strings to be equal, they must be of the same length and contain the same sequence of characters. So let's look at name1, which says John Wayne, capital J O N O H N, space capital W A Y N E, and then name2 is John Wayne, and these look pretty identical to me. If even one character is different, then the two strings are not going to be equal. So in this bottom example, we have John Wayne and Jane Wayne. A-N-E is not the same as O-H-N, so these two strings are not equal. And then in the second example, we have John Wayne with a capital W and John Wayne with a lowercase w. An uppercase W and a lowercase w are not the same thing, so these two strings are not equivalent. Okay. Some more examples in a kind of a table. 3 is 3 less than or equal to 4? Yep, that's true. 3 is less than or equal to 4. So we get a true out. 3 is less than 4. Less than or equal to tests for less than or equal. 3 equals less than 4 gives us an error because the less than or equal operator is written as less than and then the equal sign, not equals, then a less than sign. Okay, so this example would give us an error. 3 is greater than 4. Well, that's going to come out with false because 3 is not greater than 4, it's less than 4. 4 is less than 4 is going to come out with false. 4 is equal to 4, but it's not less than 4, it's not strictly smaller. So for this to be true, we need the left-hand side to be strictly smaller than the right-hand side. 4 is less than or equal to 4, that's true, because the less than or equal has the equal part into it, and 4 is equal to 4. This one, this last but one row says 3 is equal to 5 minus 2. Well, 5 minus 2 is 3, so 3 is equal to 3. That gives us a true. And then 3 is not equal to 5 minus 1. Well, 5 minus 1 is 4. 3 is not equal to 4. That's true. So this not equal thing is testing for inequality. And double equals, and I'm going to repeat this quite a few times, double equals is for comparison. Single equals is for assignment. Couple more examples. 3 equals 6 over 2. Well, we've only got a single equal sign here, so this is going to give us an error. Okay, because this single equal sign is for assignment, and we're trying to assign the value 3 to the value 3. That's not a variable, and so we get an error. 1.0 divided by 3.0 is the same as, or is equal to, 0.3333333. We're going to get a false here. This is an issue with how computers solve floating point numbers. Although these two values are very, very close, they're not actually the same value. So this is going to give us a false. And then this last one we have the string 10 is greater than 5. Well, that's going to give us an error because you cannot compare a string with an integer. You cannot compare those two things together, so we'll get an error, and the error will be something like cannot compare strings and integers. To compare strings in dictionary order, we can use the less than sign. So string 1 is less than string 2. A couple of notes about dictionary order. All uppercase letters come before lowercase letters. Spaces come before all other printable characters. Digits come before all letters. There's an appendix A for the ASCII subset of Unicode, which will give you kind of an order of precedence of dictionary order. Okay, in dictionary order here, we're talking about where they would appear in order like they would in a dictionary. Okay. The assignment and comparison operators have a lower precedence than arithmetic operators. So calculations are going to be done before a comparison or before an assignment. So normally your calculations are on the right-hand side of the comparison or the assignment operator. So here, floor plus 1 happens before I assign it to the value actual floor. I don't assign floor to the value actual floor and then add 1. Okay, the right-hand side calculation happens first, and then I do the assignment. And similarly, in the second line, if floor is greater than height plus 1, it does the calculation of height plus 1, and then compares it to floor. It doesn't compare floor to height and then add 1. Okay, the calculation happens first, then the comparison, or the calculation happens first and then the assignment. Now this goes nested branches or nested if statements. This goes back to one of the earlier programs I asked you guys to maybe write out. I didn't explain it in full detail then, but you can nest an if statement inside the branch of another if statement. So here's a kind of simple example. If you were ordering drinks, you ask the customer for their drink order. If the customer orders wine, you ask the customer for their ID. If the customer's age is over 21, because this was an originally from an American textbook, you can serve them wine, else politely explain the law to the customer, and then this else statement is aligned with this else statement, so that checking for originally if they were ordering wine or not ordering wine. If they're not ordering wine, it's assumed that they're ordering a non-alcoholic drink, so we don't ever have to care about asking them how old they are. So if they've ordered an alcoholic drink, then we also need to ask them their age. If they haven't ordered an alcoholic drink, then we can just move on with our process. Okay, so this is an example of nested if statements. Okay, as a flowchart, we ask the user for their order. Did they ask for wine? If they asked for wine, then we need to check their ID, which has another if statement. If they're over 21, then I can serve them wine. If they're not over 21, then I need to read them the law and I can't serve them wine, and we're done. If they didn't order wine at all, so they ordered a non-alcoholic drink, I can just serve them the non-alcoholic drink. Okay. So there are now 3 paths to this. The black line, the kind of teal, I guess, color, and then the purple line as well. 3 different paths through our nested if statements. Liam's Pizzeria is another example with more nested ifs. So there are 4 outcomes from this. You can order either a medium or large pizza, and then you also have a choice of the number of toppings. So you could have a medium pizza and up to 3 toppings. You could have a medium pizza and over 3 toppings. You could have a large pizza and up to 3 toppings. You could have a large pizza and over 3 toppings. Okay, and we'd have to use nested if statements to deal with this. So here is the example in a flowchart. did they ask for a medium pizza? If that's true, then we move on to how many toppings do they have. If they've got up to 3 toppings, if that's true, then we charge them this amount. If it's false, we charge them slightly less. If they didn't want a medium pizza, that means they wanted a large pizza. And again, we ask them about their toppings. Did they order up to 3 toppings? Yes, then this is how much we charge them. If that's false, then we charge them a different price. Okay, so have a little pause of the video, run through this kind of, and make sure it aligns with what you expected to happen looking at this table. Okay, here Liam has written out some example code. You'll note that he's using quite a lot of uppercase letters. That's because these are constants. Remember, constant values have uppercase letters and are separated by underscores. Okay, so he's got medium pizza base, large pizza base, and a bunch of toppings. Lower down, he's got an input, so he's asking the user if they'd like a medium pizza, yes or no, and he's storing that value in a string, in a variable called sizeString, and then he's asking the user to input how many toppings they want, and he's storing that answer. It comes in as a string, he converts it to an integer, and then he's storing that value in the variable number of toppings. And then he's kind of got this these two variables, base cost equals 0 and topping cost equals 0, 0.0, so these are going to be floats. And these are the initial variables he's going to be using to calculate the overall cost of the pizza. Okay, so the true branch for medium pizza is going to have 2 branches within this branch, as we saw when we looked at the flowchart. So if the size string is yes, if they wanted a medium pizza, then he sets the base cost of the pizza to the medium pizza base cost, and then he asks them about the number of toppings. He checks. If the number of toppings is less than or equal to 3, he sets the topping cost to the medium topping cost up to 3. Otherwise, he sets the topping cost to the topping cost of over 3 items, over 3 toppings being added to the pizza. In the false branch, this is the initial false branch here. That means that they didn't enter sizeString equals yes, which means they didn't want a medium pizza, which means they wanted a large pizza. So he sets the base cost to a large pizza base cost. And then again, he has an if statement inside this to check the number of toppings. So if the number of toppings is less than or equals to 3, he sets the topping cost to the topping cost of a large pizza up to 3 toppings. Otherwise, he sets the topping cost of a large pizza when you've ordered over 3 toppings. Okay, so now Liam's code has got the correct value, hopefully, for the base cost of the pizza and the topping cost. Finally, it just needs to calculate these things together to give an overall price. So the total cost is going to be how much the pizza base costs, based on if you've got a medium or a large, and then as well as the number of toppings you got times how much each topping costs. So he does this calculation, and then finally he prints out your pizza costs. He's using this format specifier, %.2f, so it's a floating point number represented with 2 decimal places of the total cost. And that then gets printed out to the user, and they now know how much their pizza costs, and you can charge them the correct amount. This code is been given to you over quite a few different slides. So what might be worthwhile is going back through the video and pausing it to copy down each slide one at a time and running the code to make sure it works as you expect it to. And that's a good example of looking more again at nested ifs, getting more practice of writing code, writing print statements and inputs, thinking about format specifiers, variables, constants, and so on. Okay. This kind of comes into a nice area of hand tracing. And there are lots and lots of ways of doing things like hand tracing, which will help you understand if your program is working correctly. There's also something called the rubber duck method, where you explain your code to a rubber duck. But essentially, you're creating a table of key variables, and you use a pencil and some paper to track their values. This works really, really well with handwritten or short-form pseudocode, as well as larger programs that are written more formally in a programming language. Typically, what we do is we track our location with a marker, such as a paperclip, through our pseudocode or through our code, and then we have our big table, and we change the values in that of the variables. And then we test it. So we use example input variables that you know what the correct outcome should be, and that you also want to test each branch of your code. So maybe you run through, if we looked at Liam's pizza example again, we'd run through ordering a medium pizza with very few toppings, a medium pizza with lots of toppings, a large pizza with lots of toppings, and a large pizza with few toppings. And just test that the output that we get from our system is the one that we expect. Okay, so here's the hand trace of the pizza example. Liam is setting up his table of variables. So he's got the size string, the number of toppings, the base cost, the topping cost, and then the total cost. And then he's giving them initial values. So the initial value to size string is no, so we're expecting it to be a large pizza. The number of toppings he's set to 2. The base cost initially is set to 0. It's done here at the bottom. And the topping cost is set to 0, again here at the bottom. Okay, and then as we work our way through the program, it's going to update the table. So if size string is yes, well, size string is not yes, so we skip that branch, the true branch, and execute the else branch. And the else branch tells us that the large pizza, the base cost should be the large pizza base cost. So then we're going to update the value in this table for base cost. It's going to go from 0.0 to the large pizza base cost, and then we're going to look at the next if statement. Okay, so update the variables, then the inner if, then evaluate the inner if statement. So base topping has gone from 0 to $9.99 because that's how much it costs, and then we go into our next if statement, which says if the number of toppings is less than or equal to 3, well, our number of toppings is 2, so 2 is less than or equal to 3, which is true. So we're going to go into this line of code, and we're going to set our topping cost to the toppings cost of a large up to 3, which is 50 pence. And we update our value in the table here to 0.5, 0, or 50 pence a topping. And then we keep going until we reach the end of the program. So then finally we've got to do a little bit of maths to work out the total cost. So it's the base cost, which is $9.99, plus the number of toppings, which is 2, times the topping cost. So 2 times 0.50, or 2 times 50 pence is going to be £1. So 9.99 plus 1 is going to give us 10.99. So this is our expected output. And then we can run through the program and check that it gives the same value. Okay, earlier on we looked at some other common errors of repeating code or duplicating code. The other sort of common error that you might get is the issue with floating point numbers. And this is maybe something that I mentioned in the table where I had 1.0 divided by 3.0 is 0.33333, and I told you that those aren't the same value. Floating point numbers only have a limited amount of precision, and so calculations can introduce rounding errors. And you kind of need to be aware of these when comparing floating point numbers. So for example, the following code multiplies the square root of 2 by itself. Ideally, we'd expect to get the answer 2. So we have r equals math.square root of 2.0, so we square root 2. And then we have an if statement which says if r times r is the same as 2, and if you take the square root of 2 and multiply it by the square root of 2, you should get 2. Then it's going to print out the square root of 2 squared is 2, which is what we're expecting it to print out. The else statement will run if this isn't true, if the square root of 2 times the square root of 2 is not the same as 2, it's going to print out square root of 2 squared is not 2, but, and then print out the actual value. And if we run this code, we actually get the output, square root of 2 squared is not 2.0, but 2.00000, and then ending with a 4. Okay, and this is one of the errors you commonly get when doing comparison with floating point numbers. So instead, we use something called epsilon. So we use a very small value to compare the difference to check if floating point values are close enough together. Not if they're exactly the same, but if they're pretty close together. The magnitude of their difference should be less than some threshold. Mathematically, we would write that as x minus y, well, the absolute value of x minus y is less than epsilon. Okay, so a very, very small number and checking that they're close enough together. If we do that here, so we do, again, the same sort of thing, r is the square root of 2. If the absolute value of the square root of 2 times the square root of 2 minus 2 is less than epsilon, we can say that the square root of 2 squared is approximately 2. This is just a better way of doing comparison of floating point numbers because of the issue of finite precision. Okay, so that's quite detailed, that end math section. Have a little pause of the video, maybe rewind it and watch it over, and then test it. Do some interesting things with floating point numbers and do some comparison of floating point numbers, and you should see that they don't quite equal what you expect them to because of this finite precision problem. And then try and use an implementation which uses this epsilon, this very, very small number, and compare the absolute value of the difference to this epsilon. Overall, this section was mainly focused on the if statements and how to write if-else statements, and also maybe how to trace through things by hand. So have a go at the programs contained in this section. Go back, pause the video, copy them out, maybe draw a diagram or a flowchart, try and follow things through by hand to really, really familiarize yourself with how if statements work and the flow of information. Once you've done all that, that'll be the end for this session, and we'll see you in the next one, which should be session 5.